Figure AI introduced Helix, a vision language action model that represents a major advancement in humanoid robot control. The system enables the Figure 02 humanoid robot to perform complex manipulation tasks using continuous upper body control that previous humanoid systems could not achieve. Helix controls the entire humanoid upper body, including wrists and torso and head and individual fingers, with 35 degrees of freedom at 200 Hz. The breakthrough lies in how Helix processes information and executes actions. The system uses a dual architecture inspired by human cognition. System 2 operates as a 7 billion parameter vision language model pre-trained on internet-scale data. It handles high-level reasoning and scene understanding and language processing at 7 to 9 Hz. System 1 is an 80 million parameter visuomotor policy that translates System 2's directives into real-time actions at 200 Hz. This architecture allows each system to operate at its optimal timescale. System 2 thinks slowly about high-level goals, while System 1 thinks fast to execute and adjust actions in real time. When given a command like, "Put that box on the shelf with the barcode facing up," System 2 identifies the box and determines the approach, while System 1 controls the physical movements to grasp and orient and place the barcode object. Helix is the first vision language action model to output high-rate continuous control of an entire humanoid upper body. Previous robotic systems separated upper body manipulation from locomotion, requiring different control modules for walking and object handling. Helix integrates these functions through a single neural network architecture trained on approximately 500 hours of teleoperated human demonstrations. The system demonstrates strong object generalization. Figure robots equipped with Helix can pick up thousands of household items they have never encountered before simply by following natural language prompts. In demonstrations, robots successfully manipulated entirely novel groceries, including items with diverse shapes and sizes and materials that were never seen during training. The robots handled bags of cookies and cans and produce and other objects without requiring task-specific programming. Helix enables multi-robot collaboration using a single neural network instance. Two Figure 02 robots can operate simultaneously, coordinating on shared manipulation tasks. The robots respond to natural language commands like "hand the bag of cookies to the robot on your right" or "receive the bag of cookies from the robot on your left and place it in the open drawer." This marks the first demonstration of flexible and extended collaborative manipulation between multiple robots using a vision language action model. The robots coordinate through shared understanding rather than explicit role assignments. Both robots operate using identical Helix model weights, eliminating the need for robot-specific training. They achieve coordination naturally based on language prompts and visual observation of each other's actions. This capability extends beyond simple pick and place to complex sequences involving multiple handoffs and placement decisions. Figure AI applied Helix to logistics package, manipulation, and triaging in warehouse settings. This application demands human-level speed and precision and adaptability. The robots handle packages of varying sizes and shapes and weights and rigidity, from rigid boxes to deformable bags. The system determines optimal moments and methods for grasping moving objects on conveyor belts while reorienting packages to expose shipping labels for scanning. Helix includes several technical refinements that enable industrial performance. Implicit stereo vision provides rich 3D understanding for precise depth-aware motion. Multi-scale visual representation allows the lower-level policy to capture fine-grained details while retaining scene-level understanding. Learned visual proprioception enables each robot to calibrate itself, ensuring seamless policy transfer across multiple units without extensive retraining. Figure AI developed a test-time technique called Sport Mode that achieves faster than demonstrator-learned behavior. The system won policy's output action chunks, representing series of robot actions at 200 Hz. By linearly resampling action chunks to shorter trajectories and executing at the original control rate, the system achieves up to 50% speed increases without modifications to training procedures. This allows robots to handle packages faster than the humans who demonstrated the tasks. The system runs entirely on embedded low-power GPUs on board the robot. This makes Helix commercially viable for deployment without reliance on external computing resources or internet connectivity. Onboard processing reduces latency, allowing robots to respond quickly to commands and interact with environments in real time. This represents a crucial step toward making humanoid robots practical for homes and varied work environments. Unlike prior approaches that required separate neural network models for different tasks, Helix uses a single set of weights to learn all behaviors. The system handles picking and placing items and using drawers and refrigerators and cross-robot interaction without task-specific fine-tuning. Once trained on one behavior type, the knowledge generalizes to related tasks through the vision language model's semantic understanding. Brett Adcock, founder of Figure AI, stated that Helix represents the most significant AI update in the company's history, saying, "Helix thinks like a human, and to bring robots into homes, we need a step change in capabilities." Helix can generalize to virtually any household item. Like a human, Helix understands speech and reasons through problems and can grasp any object, all without needing training or code. Figure AI trained Helix using an auto-labeling vision language model to generate natural language instructions from video demonstration data. This approach reduces the need for extensive manually labeled datasets. The training process captured human teleoperators performing tasks, while the system learned to associate visual observations with language commands and physical actions. The 500 hours of training data proved sufficient to achieve robust generalization across thousands of objects. Figure announced deployment at an unnamed second commercial customer facility, with CEO Brett Adcock stating it took only 30 days to deploy humanoids on site. Observers speculate the customer is Amazon or Walmart based on the logistics focus. Adcock indicated he sees a path toward manufacturing 100,000 Figure humanoid robots over the next 4 years based on demonstrated customer demand. The company secured partnerships with major manufacturers. BMW deployed Figure robots for tasks like inserting sheet metal parts in automotive manufacturing at its Spartanburg, South Carolina plant. These industrial pilots test reliability and speed and integration with existing workflows. The robots work alongside human employees in brownfield facilities without requiring extensive facility modifications. Figure AI is reportedly in advanced talks to raise $1.5 billion in Series C funding at a valuation of nearly $40 billion. This represents a 1,400% increase from its 2024 valuation of $2.6 billion. Investors include Nvidia and Microsoft and Jeff Bezos through Amazon and Parkway Venture Capital. The funding reflects confidence in Figure's technical progress and commercial trajectory. Figure AI's Helix system demonstrates capabilities that previous humanoid robots could not achieve through unified neural network control of upper body manipulation combined with language understanding. The shift from task-specific programming to general-purpose learning through language commands represents a fundamental change in how humanoid robots operate. Subscribe to AI Tech Academy for ongoing coverage of humanoid robotics breakthroughs. Drop a comment with your thoughts on robots that learn tasks by understanding language. Thanks for watching, and we'll see you in the next one.